This is the circuit of Class C Power Amplifier which we will be implementing on MultiSim. The tank circuit is used to remove the distortion and get sustained oscillations. We have to remember that we get sustained oscillations only at resonance frequency, which is 51.9 kHz. So input will be provided as 4 volts peak to peak at resonance frequency of 51.9 kHz. The negative voltage of 1 volts is provided to shift the Q point below cutoff. Of Class C Power Amplifier. The circuit is will be seeing the practical in two parts. The first will be to find out the peak output voltage. So for that, simulate it. Click on the CRO, stop the simulation, measure the output. It should come out approximately 30 volts. So measure the peak to peak value. At panel A, peak to peak value is 28.96 volts. So approximately we should get 30. Practically we are getting it as 28.96 volts. The next part is to find the maximum frequency of oscillation, which is 59.1 kilohertz. Remember, Class C works at maximum frequency of oscillation. You will get the maximum efficiency. So 51.9 kilohertz, 2 volts peak voltage, we will get maximum efficiency. So let us find out the efficiency of this Class C power amplifier. To find out the efficiency, we need to connect the wattmeter. Wattmeter gives the power. So one wattmeter at the input side, another wattmeter at the output side. So M1 is the wattmeter at input, M2 is the wattmeter at the output. Positive of the voltage is connected to VCC because DC power is VCC into IC. Negative will be connected to ground. For current comes in series, so we will be opening this loop and we will be connecting your current meter. Positive over here, negative to the collector. Similarly, at the output side, first open this link of the output. Current flows over here, positive and negative over here. Voltage across the load resistance. So voltage will be over here and the negative will be grounded. This is how the wattmeters will be connected. Again I am repeating, positive to VCC, negative of voltage to ground, positive of current to the tank circuit and negative to the collector. At the output side, open the link, connect the current meter positive to the capacitor, negative to the load resistance, voltage across the load resistance positive and negative to ground. Run it. Click on the wattmeters. Show certain readings. So M2 is the output power and M1 gives you the input power. So efficiency is given as output by input. So let us write that. So efficiency is P out divided by P in, which is equal to over here 100.881 divided by 105.106, sorry, We can stop the simulation and see it is 106.312. Since it is milli, so we are neglecting the milli because it will get cancelled, and efficiency is given in percentage, so this comes out to be equal to, I think, approximately 91 or 92%. So 100.881 divided by 106.312 is 94.89%. So the efficiency is 94.85%. Theoretically, the efficiency, we know that if class C has the maximum efficiency. So over here also we are getting the efficiency as 94.85, which is good enough. The next step over here is we can find out the spectral bandwidth of class C power amplifier by just changing the frequency from here. Start from 47 kilohertz, go on changing the frequency, run the simulation, see the output power and calculate output and input power and calculate the efficiency. Again, go stop this, change the frequency to, suppose we are changing it to 50 kilohertz. So 47 we are changing it to 48 kilohertz. Simulate it. See the change in the output power and the input power. That was called the change in efficiency. So we'll be plotting a graph between frequency and efficiency to get the spectral bandwidth versus efficiency. So if you can see, as you go on increasing the frequency, the efficiency also goes on increasing. At resonance, it achieves maximum efficiency and then it falls down. From the maximum, multiply it by 0.707, which is 3 dB down. So 0.707 of the maximum value will cut the graph at 2 points. The first point is giving FL, which is 50 point, which comes approximately at 50.3 kilohertz, and the second point gives FH, which comes out approximately 53 point kilohertz. Bandwidth is FH minus FL, so it is coming out approximately 2.7 kilohertz. So in this way you can find out the spectral bandwidth also.